Okay, which row shows the minimum number of moles of oxygen needed for the complete combustion? You know, complete combustion results in the formation of carbon dioxide and water and large amounts of energy, right? So for the complete combustion of 1 mole of named alcohol, now for this you just need to balance the equation, sir. Write down the combustion equation for butanol and propanol. Now you guys may wonder, sir, it's butan 1-ol and butan 2-ol, propan 1-ol and propan 2-ol. These are just the isomers of alcohol, right? They're just different structural formulas of alcohol, but the equation would remain the same. Whether it's butan 1-ol or whether it's butan 2-ol, the number of the moles of oxygen required to combust this are going to be the same, because you realize if it's butan 1-ol or even butan 2-ol, the formula is going to be the same. That's what an isomer is. It has the same molecular formula but different structural formula. So butan 1-ol, what's the formula for it? C4, but means 4 carbons, so C4H is twice the number of carbons plus 1, that's 9, and OH. Similarly, propanol or propan 1-ol, propan 2-ol, doesn't matter. Prop means 3 carbons, so 3 carbons, hydrogens are twice the number of that plus 1, so that's going to be 6 plus 1, 7, OH. And what is going to happen? They're both going to react with oxygen and going to give you carbon dioxide and water and large amounts of energy. Gives me carbon dioxide and water and large amounts of energy, right? Now the question is, how do you balance this out? Well, it's pretty easy. The number of carbons that you have in the alcohol or alkene are the number of moles of carbon dioxide that are going to form. So if you have 4 carbons here, 4 moles of carbon dioxide are going to form. And the number of hydrogens that you have in the fuel, half of it would be converted into H2O. So if you have 10 hydrogens here, just divided by 2, what do you get? 5, because again 5 times 2 is what? 5 times 2, that's 10. 9 plus 1, that's 10, right? So balanced, hydrogens are balanced. Now in the end we balance the oxygens. 4 times 2, that's 8, and 5 times 1, that's 5. So 8 plus 5, you have 13 oxygen atoms on the right hand side. Now you also need 13 on the left. 1 is already present here in the alcohol. How many more do you need? I need 12 more. So what should I multiply 2 with to get 12? X is equal to 12 over 2, and I believe we've gotten our answer. X is equal to 6. We're going to plug in the 6 here. What was this? This was butan 2-ol, butan 1-ol, doesn't matter, but it needs 6 moles of oxygen, and we have 6 right here. Therefore areno is the correct option. The problem with propanol, propan 1-ol, propan 2-ol, doesn't matter, but the problem with it is if you balance it out, you have 3 carbons here, 3 carbons would be here, 3 carbon dioxides obviously. You have 8 hydrogens on the left. You should have 8 divided by 2, that's 4 on the right, because once you multiply 4 with 2, you get 8 hydrogens again, right? And then you need how many oxygens? 3 times 2, that's 6. 6 plus 4, that's 6 plus 4, that's 10. So plus 4, that's 10. So you have 10 oxygens on the right. How many oxygens do you need on the left? Now you already have 1 oxygen present here. I need 9 more. So what should I multiply 2 with to get 9? X is equal to 9 over 2, that's 4.5. You know, I'll just write 9 over 2 here. So there's no 9 over 2 here. If there was 9 over 2, then there would have been a problem, and this MCQ would have been invalid because there can't be 2 correct options. So the correct option right here is butan 1-ol, right? It could have also been butan 2-ol if it said 6 moles here. But he himself, the examiner himself, has given this on purpose because he knows these two would require the same moles of oxygen. These two would require the same moles of oxygen. So he's just played with the names here. Okay, bye.